back into our beloved friend of, well, I guess, solving equations. So we've been solving many equations before. We solved quadratic, we solved linear, we solved many things. And today we're just going to be solving trigonometric functions. So if you don't notice a huge problem, like I did when I studied this very long time ago, you realize that, a trig function is continuous. So it repeats itself essentially over and over again. So that means there's going to be an infinite amount of, well, x-intercepts. And essentially when we're solving for an equation, we're solving for the x-intercepts. So today we're going to go ahead and try to look and see how we're actually going to generalize our solution. Basically write something like this, how many solutions there are, and how do we write them. So first, let's actually go ahead and solve this. So we can realize that our, well, so-called x factor in this case is actually theta, right? This is our factor. So since if we want to isolate for theta, we'll have to move the 1 to the other side. So that becomes 2 sine theta is equal to 1, right? And then we isolate sine theta is equal to 1 over root 2. And then we think about our special triangles, right? Which one is yes, which one was 1 over root 2? Think about it. Or it's 2 over 2. Think about it, and you will realize it was pi equals 45 degrees, right? Now you might think we're done, but unfortunately we're not done. If this was the end of it, I would be very happy, but no. And this is where most people trip up. Let's draw a sine graph real quick. I'm supposed to draw like this, right? Now, look at it. There, for every 360 degrees, there's going to be two different, two different solutions. So in our case, we found the first solution. It's 45 degrees. But what about the second solution? So we're going to look at it. And we're going to apply the related angle rule that we talked about earlier. Related angles and correlated angles. So a while back, we realized. So sine is positive in this case. Because sine theta is equal to root 2 over 2. Right? And now let's look at which case it could be. C-A-S. Oh, no, hold on. C-A-S-T. So for sine to be positive, it can only be in those two areas. So we understand it's 45. So there has to be another angle here that gives the same exact value. And to find this angle, what are we going to add? We're going to add 90. So 45 plus 90 is going to go ahead and give you 135 degrees. And we found our answer. Let me just write it out. 45 degrees and 135 degrees. Now, if you don't trust me, go ahead and pull out your calculator. Just do it. Check it. Check your answer. And be like, am I right? Am I wrong? Check it. And then, I want to also talk about some people be like, hey, wait, isn't there a transformation of this? Yeah, but the thing is, this only applies for height, so it doesn't really matter. Now, there's another graphing calculator method, and and you can actually solve it with the graphing calculator for all of the questions that we're going to do. However, I am not going to let you use a graphing calculator on the test. So this method is kind of useless. I just want you to know that it's possible and you can do it. And as well, the graphing calculators are actually banned on all Canadian schools. So if you have a graphing calculator that you're using, you're actually not allowed in tests or in any contests. So this is going to show up only once in this entire class because the rest we're just going to do it by hand. So now we have done it once. Let's do it again. Let's see what this is. So 3 cos theta equals cos theta plus 1. Something we can do here is, why don't we move everything to one side first? So 3 minus 1, that's going to give you 2 cos theta. And that's going to give you 1. And then cos theta is equal to 1 over 2. And now we think. So remember the special triangles that I taught you like around, I think 3 or 4 classes ago. So we think about it and be like, okay, which angles are there? Which angles are these? First one is 60. 60 degrees. So we can actually come up with a generalized idea of how we can solve trigonometric, equations. So rule number one is that we're going to move everything to one side. Rule number two is that we're going to isolate for the theta. Rule number three, we're going to find our first value. Now, what do we do at step number 4? We look at cosine theta and we see if it's positive or not. If it is, okay, let's use the CAST rule, otherwise known as the O student take calculus. So we see 60 falls in here, which everything is positive, so it makes sense. So the other one for cosine to be positive has to be here. So how do we get to that? Well, I think many of us already has an answer. If we have a 60 here, we just simply have to do this. So that's negative 60. And then obviously, this is going to be 300. So our final answer is 60 degrees and 300 degrees. Again, if you're not sure about it, go ahead, go use a calculator, and check me out. Check if cosine of 60 is equal to the cosine of 300. And plug everything back into this equation, and you will see if I'm right. Now, we're going to solve by factoring. And this is where I would introduce an idea of substitution methods. So sometimes when we look at it, we're not really able to see it right away. So what do we do? We'll substitute. So let's say if cos x equals to this u, so we call in a u substitution. So 2, remember, I have to write something else as well. Cos x squared, cos squared x. This is equal to cos x squared. Okay, I just want you guys to know that. So now we have set that down. So this would be 2u squared minus u minus 1 equals 0. And that would just bring it back to a quadratic, that we solved maybe grade 8 probably. So that would be 1, 2 on the left side and 1 and negative 1 on the right side. So negative 1 and 1. So we can go ahead and be like u minus 1 2u plus 1. Right? We're done. Now since we substituted it, we actually have to substitute it back. So u, we know it's cos x. So cos x is equal to 1. And then 2u. So I just directly substituted it. You can do this. You can expand this step because if you don't know how to do it, 2 cos x equals to negative 1. Alright, no problems in our isolation. So for cos x to equal to 1, which is, the very top, what can it be? It can be either 0 or 360 degrees. Wow, why am I writing so bad? 360 degrees. Right? That's the only two options that we have. However, for negative 1 over 2, we have a lot of options. So first, let's isolate it even further. So this becomes negative 1 over 2. So we see cos is negative. What does that mean? That means we're going to be in the second and third quadrant because using CAST rule. So first, let's find the first one. So first one, if you use, memorize some good formulas, understand it, the first answer is going to be 120 degrees, otherwise known as 2 pi over 3. And now we see something in the third quadrant that's 4 pi over 3, right? And then now we basically multiply it out, so 4 times 180 divided by 3, 240. Now, I want you to understand something. This is a quadratic equation. We're going to have 4 different answers. So please do not forget a single one, because if you forget a single one, you're out. And then we also noticed in the previous question, it's all asking in degrees. So degrees. However, in this question, we're asking you in radians. So whenever we ask in radians, you're always supposed to give your answer in radians, which I did on this case. However, since radian conversions to degrees is not really a hard thing, and it only takes a couple seconds, so most of the time on an actual, test or exam or something where you have a decent amount of time, I personally would recommend you to just go ahead and write both because, hey, some teachers are picky about it, some teachers aren't. Now we read the question first. Solve this equation. Express the answers as exact solution and approximate solutions. Ooh, not good. So let's first, do the substitution thing again. So 2u squared minus 7u plus 3. So this is a complex trinomial. Well, not so complex in my opinion, but so as we can see, we have a negative number, so it has to be negative here, negative 3 and negative 1. Now we have done that, u minus 3, 2u minus 1. So that gives us sine, wow, sine x goes to 3, or 2 sine x, sorry, I should just write this, sine x equals to 1 over 2. So we solved this before, which, well, I guess we did. So we solved that before. So we're going to do this easy one first. So if we solved it before, I'm just going to take the answer. Wow. I'm just going to take the answer from before. So sine x equals to 1 over 2. The solutions for this is 30 degrees and quadrant 4, which is 330 degrees, which I believe. Let me just check. 5 times 180 divided by 6, so 150, sorry. CSAT. Oh, sorry. So so the answer is 30 degrees and 150 degrees, right? So that's that part. However, now that we're done the easy one, let's think about sine x equals to 3. When does sine x ever, in fact, if it ever does, when does it ever approaches the number 3? I mean, I thought it was limited at 1, right? So exactly, sine x equals to 3 does not exist. This is a failed equation. So essentially, even if we have a quadratic, there is still a possibility that we're going to have, you know, we're going to have only two solutions because one of them is invalid. So 30 and 150. The radian versions are pi over 3. This is 5 pi over 6. Yep. So now it also asks us to give in exact solutions. So we're going to do that. Go ahead and do pi over 3. Pi over 3. You're going to get a number of 1 point... Sorry, pi over 6. What am I thinking? So you're going to get a number of... I was thinking about it. Pi over 6. You're going to get a number of 0.52 because you're rounding to the hundredth. I got 0.523, so I round down. Now 5 pi over 6. 5 times pi over 6. That's going to go ahead and give you 2.62. So my answer was actually 2.617, which I will round up, so it's 2.62. Therefore, we have our answers. And now let's go to example 5. So we're going to use trig identities, which we just learned last class, and I know many of us hate it. So we look at it. What can we do? Well, what is there for us to do in this? Is there anything for us to do? So we haven't learned any identities. In fact, well, we learned, but not too much. So I want to talk about this identity. Because really, that's the only one that we can really see, right? So if we go ahead and organize this out, this is going to give you 5 plus sine x. 6 goes squared x. So we want to kind of simplify everything out first. So let's look at it. cos x squared, cos squared x is equal to 1 minus sine x. So let's simplify it out. So I'm going to substitute this in here. So now I'm going to have 6 minus 6 sine x is equal to 5 plus sine x. Right? Now we collect the like terms. So this becomes 7 sine x is equal to 1. So 7, 7. Wow. What's going on? Let me just refresh the page. So we will have, yeah, hold on. Okay. So we're back, I believe. Okay. So we're back to question number 5. So, oh, I also forgot a square root. So this will become 6 minus 6 sine squared x. So now that's a quadratic. So instead of having this, so 6 sine squared x minus sine x minus 1 equals 0. Now you go ahead and do the factoring, and then you will get two things. So sine x, wow, sine, what? You'll get two answers. Sine x is equal to 1 over 2, negative 1 over 2, and sine x equal to negative 1 over 3. 1 over 3. So now we solve it. Remember, it's asking us in degrees. So 210, and then that's for the 1/2. So 210 and 330, right? And then for the 1 over 3, you can go ahead and figure that out yourself. So I want to talk about the word problem, because that one is a little, well, I don't like this one a little bit. So we have the equation, and this is our, well, this is likely going to be our only question that's ever going to come up in grade 11 that's going to include tangent, because, well, I don't believe they really like to use tangent that much here. So we have the question. An engineer uses this equation to calculate the angle at which a curved section of a highway should be banked. In the equation, x is the angle of the bank and v is the speed limit of the curve in kilometers per hour. Calculate the angle of the bank to the nearest tenth of the degree if the speed limit is 100 kilometers per hour. So essentially, you're just going to plug this into the calculator. So 100 km to the power of 2 over 224,000. Let's just do that. So 100 squared, that's going to give you 10,000 over 2,000. 224,000. It's going to go ahead and give you a very small decimal number. It's going to give you, hold on, so 100,000 over 22400. It's going to go ahead and give you 0.04. And then we're going to go ahead and inverse tangent, because remember, this is, this is a degrees. This is tangent x equals to 0.04464. So let's go ahead and inverse tan that. And let's go ahead and round it to the nearest tenth of a degree. So the answer for you, for us, should be 2.6 degrees. So the answer was, for me, was 2.556, which I will go ahead and round up. So 2.6. So you're going to go ahead and write your conclusion statement. The angle of the bank is 2.6 degrees to the nearest tenth of a degree. So let's go ahead and do B. The 4 turns at Indianapolis Motor Speedway are banked at an angle of 9.2 degrees. What is the maximum speed through these turns? Just go ahead and plug X now. So that's 10 equals 9.2 degrees. then let's go ahead and isolate for v. So first, tan of 9.2, we're going to leave it very last. So let's isolate for v. So v squared is equal, so v is gonna go ahead and equal to square root 2, 2, 2, 2, 4, 0, 0, 0, and then tan of 9.2 degrees. Let's go ahead and calculate that. So that you're gonna go ahead and get 190.47, which rounds down to 190 since you're running to the kilometers per hour. And there we go. We're done the question. So that is the class for today. I believe it's very straightforward. And the next class, I think it's review. And we are done our most nightmare unit. And next unit, it's gonna be, I'm pretty sure it's gonna be sequence, but I might do the economy. Well, I guess the finance unit first. But we'll see how that goes. Anyways, that's it.